Welcome to the game-changing world of functions. Imagine having a magical recipe book where each recipe can be used over and over, customized to your taste, and shared with friends. That's exactly what functions are in programming, reusable blocks of code that make your programs modular, efficient, and elegant. From simple calculations to complex operations, functions are the building blocks of every great program. Today, we'll master the art of creating, calling, and leveraging functions to write cleaner, more powerful code. Let's unlock the power of write once, use many times. Functions are named blocks of reusable code that perform specific tasks. Think of them as mini programs within your program, each designed to do one job well. A function is like a machine. You put ingredients in, inputs, it processes them according to its recipe, code, and gives you a result, output. Once built, you can use this machine as many times as you want with different ingredients. Functions offer powerful benefits. Reusability saves time. Modularity simplifies complex problems. Readability makes code self-explanatory. Centralized debugging reduces errors. And easy sharing promotes collaboration. Let's dissect a function to understand its components. Every function has a specific structure that Python recognizes. A function starts with def, followed by its name and parameters in parentheses. The colon signals the start of the function body, which must be indented. The return statement sends a result back to whoever called the function. Let's visualize how data flows through a function. Parameters come in, processing happens inside, and results go out through return. Let's start with simple functions and gradually build up to more complex ones. Remember, every expert was once a beginner. Functions can have no parameters, one parameter, or multiple parameters. Default parameters provide flexibility, they're used when no value is provided. To use a function, simply call it by name with appropriate arguments. Let's clarify an important distinction. Parameters versus arguments. Understanding this difference will make you a more precise programmer. Parameters are placeholders in function definitions, while arguments are actual values passed when calling. Use positional arguments for required values, keyword arguments for clarity, and asterisk args or asterisk quargs for flexible parameter counts. Functions can return values, return nothing, or return multiple values. Understanding return behavior is crucial for effective function design. Functions without explicit return statements return none. You can return multiple values as tuples. Use early returns for validation. And implement conditional logic in returns. Good return practices make functions predictable and easy to use. Understanding scope is critical for avoiding bugs and writing maintainable code. Scope determines where variables can be accessed in your program. Local variables exist only within their function. Global variables can be read from anywhere but should be modified carefully using the global keyword. Nested functions can access outer scopes. Best practice: pass data as parameters rather than using global variables. Let's explore real-world function examples that solve common programming problems. We'll look at them one by one so you can focus on each concept clearly. First, an input validation function. It checks whether the email contains an @ symbol, and that both paths are non-empty. This is a basic but effective validation step. Next, a data processing function that converts numeric scores into a letter grade. It also gracefully handles the case when no scores are provided. Here's a string manipulation example. It removes all non-digit characters from a phone number and formats it into the common US style. If the length isn't 10 digits, it returns an error message. For a mathematical example, this function calculates compound interest over time, supporting different compounding frequencies. Here's a list processing function. It identifies duplicate items by tracking what has been seen already. Finally, a file path helper. It replaces invalid file name characters with underscores, ensuring safe file naming across operating systems. Great functions are self-documenting with clear doc strings. Good documentation makes your code professional and helps others understand your intentions. Here's a detailed doc string for a BMI calculator. It describes what the function does, its parameters, return value, possible exceptions, and even provides examples and category notes. You can access a function's doc string directly with the _doc attribute, or view it nicely formatted using Python's built-in help function. This is a Google-style doc string. It lists arguments, returns, and raises in a clear format. Here's a NumPy-style doc string, which uses section headers like parameters, returns, and examples. For simple functions, a one-line doc string is enough. Finally, here's an example combining type hints with doc strings for maximum clarity. Whether you use Google style, NumPy style, or short one-liners, consistent doc string formatting makes your code much easier to maintain and understand. Higher-order functions either take other functions as arguments or return functions. They're powerful tools for creating flexible, reusable code patterns. First, higher-order functions can take other functions as arguments. Here, apply underscore operation takes a list and applies a given function to each element. Second, they can return other functions. This is called a closure. The returned function remembers the variables from its creation. Decorators are higher-order functions that wrap and modify other functions. Here, our timer decorator measures how long a function takes to run. We can compose functions, combining them so the output of one becomes the input of another. Python comes with built-in higher-order functions like map, filter, and reduce, making common transformations concise and readable. Finally, a real-world example, a validator factory function that builds custom text checkers. Here we create specific rules for passwords and usernames. Recursive functions solve problems by calling themselves, breaking them into smaller, similar subproblems. A classic example is factorial. The base case stops at 1, and the recursive case multiplies n by factorial of n-1. Fibonacci numbers are also recursive. Each term is the sum of the previous two. But this naive approach repeats work and is slow. Recursion is great for tree-like structures. Here, we count files in a folder and all its subfolders. You can also sum numbers in a nested list by recursively diving into sublists. Robust functions handle errors gracefully. Good error handling makes your functions reliable and provides clear feedback when things go wrong. Let's start with input validation. This function checks that both arguments are numbers and prevents division by 0 by raising clear exceptions. Sometimes, instead of letting your function crash, You can return a default value when something goes wrong. This is defensive programming. You can handle multiple exception types in stages. Here we first try converting to an integer, then fall back to a float before giving up. Custom exceptions make error handling more readable and precise. This password validator raises different errors for length and complexity problems. Logging is essential for diagnosing problems in production. Here we log the error with full traceback before re-raising it. Graceful degradation means your app still works, even if some parts fail. Here we fall back from cache to database to default values. Context managers make sure resources like files are closed properly, even when an error happens inside the block. Finally, here's a robust function template that validates inputs, uses retries, and raises meaningful exceptions when things go wrong. In summary, validate inputs early, use specific exceptions, provide clear messages, log errors, clean up resources, degrade gracefully, and document your exceptions. Testing ensures your functions work correctly and continue working as you make changes. Good tests are your safety net and documentation rolled into one. We'll start with the function we want to test. A simple tip calculator that returns tip amount, total amount, and per person share. First, a basic manual test. We check that for a $100 bill with 20% tip split between two people, the results match expectations. Next, we test edge cases, 0 bill, 0 tip, and very large numbers, to make sure our function behaves correctly in unusual situations. We also verify that invalid inputs raise the correct errors. This protects against unexpected crashes. For more structured testing, we can use the unit test framework, which lets us group related tests in classes. Mock testing lets us replace external dependencies with controlled values, perfect for APIs or services we don't want to call during tests. Testing includes basic functionality, edge cases, error conditions, and properties that should always hold. Use unit test for structure, mock external services, and keep your tests readable. First, in web development, functions handle user management. Here we see examples of creating a user profile with validation, and authenticating logins with password checks and session tokens. In data processing, functions extract valuable insights from raw information. For example, analyzing sales data to find best sellers, or cleaning messy customer records. Automation functions save time by performing repetitive tasks, like organizing your downloads folder into categories. These examples show how functions power real applications, from web platforms to automation, analytics, monitoring, e-commerce, machine learning, and beyond. Let's consolidate everything you've learned about functions, the fundamental building blocks that make programming powerful and elegant. Key concepts include function fundamentals like parameters and scope, design principles emphasizing single responsibility and clear naming, advanced concepts like recursion and higher order functions, and best practices for maintainable code. Functions transform complex problems into manageable, reusable solutions. Let's begin with our task manager class. We start with imports, defining our class, initializing task storage, and creating the add_task method. Notice the input validation, default arguments, and automatic ID generation. Next, we add methods for completing tasks, filtering by priority, and finding overdue items. Each function is short, clear, and focused on one responsibility. Finally, we include a reporting function and a private helper method. Our usage example shows how all these methods work together to build a functional task system. This example proves the power of functions. They make your code reusable, modular, and elegant. Master them, and you master the art of programming. Thank you for joining this journey through Python functions. Now, go write functions that your future self will thank you for.